Welcome back. In this video, we will learn about covalent compounds and how to name them. In a previous video, we learned that ionic compounds are made of cations and anions. Covalent compounds, instead of being made from ions, are made from atoms held together using covalent bonds. Unlike ionic compounds that have millions, billions, or even more of each ion, covalent compounds exist in individual, discrete pieces called molecules, and these are made from as few as 2 atoms. The easiest way to identify the 2 types of compounds is what type of atom is used in making them. Ionic compounds must be made from a metal and a nonmetal, or they will contain at least 1 polyatomic ion. In contrast, our covalent compounds are going to be made only from nonmetals. Another big difference between ionic and covalent compounds is that ionic compounds always exist in a fixed ratio of ions. Covalent compounds, even those made from the same pairs of elements, can come in many different varieties. For example, nitrogen and oxygen can be combined into a number of unique covalent compounds. These include, but are not limited to, NO, NO2, N2O, NO3, N2O4, and even N2O5. Notice that NO3 is neutral. This is not NO3 minus. NO3 minus is nitrate, a polyatomic ion, while NO3 is a neutral covalent compound. Now, all of these compounds have different chemical and physical properties. So, how do we name these different compounds with different numbers of each element in order to tell which one we're talking about? Well, for a covalent compound, we're going to use prefixes to indicate the number of each element. So, the prefixes we will use are, for 1, mono, 2 is di, 3 is tri, and 4 has a prefix tetra. From there, 5 is penta, 6 hexa, while 7 is hepta with a P sound, 8 is octa, 9 nona, and 10 deca. So you will need to identify the number of each element using these prefixes. There is, however, a single standard exception. If there is only one of the first atom, you do not need to include the mono prefix. However, you do need to include the mono prefix if there's only one of the second atom. You will also need to name the second atom as though it were an anion. So if we think about water, H2O, it will have the chemical name dihydrogen monoxide. Let's go back and name these compounds from before. NO, only one N is nitrogen. And then only one O, but we do need to name mon. So this is monooxide, usually just monoxide. Again, one N is just nitrogen since it's the first element. But now I have 2 oxygens, dioxide. Moving on, 2 nitrogens, we do need to specify dinitrogen. And then 1 oxygen, monoxide. Now I have 1 nitrogen again to start off with. So we have nitrogen. 3 oxygens, so this one will be trioxide. N2O4, dinitrogen. And then 4 is tetra, so this is tetroxide. Finally, 2 nitrogens, dinitrogen. And 5 oxygens, pentaoxide. There is one more rule when naming covalent compounds. Hydrogen only makes one-to-one compounds with the halogens. So for HF, you do not need a prefix. It's just hydrogen fluoride. HCl, hydrogen chloride, HBr, hydrogen bromide, and HI, hydrogen iodide. No prefix is necessary. Let's do a few more examples. What are the names of H2, Se, PF5, and SO3? Well, H2Se, I've got two hydrogens, so dihydrogen. And then a single selenium, so mono. But this isn't monoselenium. Remember, we have to end with the "ide" suffix whenever we're naming our second compound here. So this is monoselenide. PF5, only a single phosphorus, and it's our first element. So we don't need to worry about putting a mono prefix, just phosphorus. Followed by 5 fluorines, pentafluoride. And we'll finish off with SO3, sulfur trioxide. Again, it's really easy to get SO3 confused with SO3 2-, the polyatomic ion sulfite, but this neutral compound is sulfur trioxide. Now, turning the names back into formulas is really easy with our covalent compounds. Remember, the prefixes already give us the number of each element. So not having a prefix like in phosphorus will also tell us that we only have one of that atom. Let's do a few examples here. We'll start off with boron trichloride, followed by nitrogen diiodide, and finish off with tetra phosphorus hepta sulfide. You've probably already got this first one, a single boron, and 3 chlorines, BCl3, nitrogen, diiodide, Ni2, and finally tetraphosphorus, P4, heptasulfide, S7. The formulas of these covalent compounds are also called molecular formulas, and each of the individual units is called a molecule. These do not have to be the simplest whole number ratio of atoms for each element like they were in our ionic compounds, the empirical formulas. The molecules NO2 and N2O4 have the same 1:2 ratio of nitrogen to oxygen atoms, but these are different compounds and they have different molecular formulas. You will need to be able to convert between the names and formulas of both ionic and covalent compounds this semester.